Hello everyone. This is Team Enhanced Space Defense Force, the Anti-Space Dust 01 team. My name is Pratik Kumar Singha. Along with me are my team members Akshat Mohite, Krupal Dabhare, Pradnesh Matre, and Sejal Jain. We all are from India, and here it comes the first slide. Next, please, and over to Sejal.
Yeah, hi everyone. When we have heard about Apollo astronauts, it's really exciting for them for the moonwalking. But we all have seen that they always have worried about dust. So it's like, why do they are so much worried about so much of dust present on the surface of the moon? So let's just find out what are the problems faced by them. They usually it is due to reduced visibility, difficulty in breathing, and respiratory problems. The dust particles indeed are very sharp that they can wear into the fabric of the spacesuit, and it increases the friction at the mechanical surfaces, trouble in moonwalking because dust enters gum up with the joint, and dust can enter into the crew cabin, which can damage the equipment and can destroy the vacuum seals of the sample collectors. And there are many such reasons, and hence it becomes difficult for them to conduct their expedition. Can you please change the slide? Yeah. So here we have found out that there are different things about the lunar dust. So this is a basic picture about it's a picture about a microscope view of the lunar dust, and we have seen that the dust is susceptible to magnets because it contains metallic iron embedded in a glassy shell. And we have also seen that permanent magnets, a small permanent magnet can be a way to remove the dust particles because it's made up of iron. And here we have the chemical composition where it is made up of 50% SiO2, Al2O3, all the oxides and iron. So presence of oxides here can be used to extract oxygen from the lunar dust. And also melting the dust particles in microwave is very quick. Like it takes less time than to boil a cup of tea, and the byproducts obtained are damn amazing. So, what are the solution to mitigate the dust? So, yeah, we have found our own solution. Uh, can you please change the slide? Yeah. So, this is our customized clean room which we have planned to build. So, yeah. So, can you please go to the next slide for the working mechanism? Yeah. Here's our mechanism. We have sealed doors. We have yeah. You can go back to the picture, previous slide. So we have a clean room, which is customized by ourselves, not like the normal clean rooms found in the space centers. So here we have a clean room structure with the two coils, which generate magnetic fields. We have sealed doors on the two sides for the entry and exit of the astronaut. We have sharp air blow. We have arc-shaped air blowers. We have platform where an astronaut can stand. We have a conveyor belt to transport the dust, and we have a mesh to transport the dust to the conveyor belt. So the basic principle on which it works is we all know that current carrying coil induces magnetic field. So and that could be found out using right hand thumb rule. So once an astronaut comes in the clean room and stands in between a coil which is of 2 meter in diameter, which is very big enough. So and the system gets on. So when the current passes, it induces magnetic field, and coil one here is movable and coil two is stationary. So once the coil one moves, all the moves vertically, all the dust particles get attracted. And once the coil one reaches the distance of 1 meter, which is equal to the radius of the coil, it works on Helmholtz principle, wherein a uniform magnetic field is generated in the entire room. So this can attract all the dust particles, and 90 to 95% of dust gets cleared. So, and the remaining dust, and suppose if there's any remaining dust in the vent, it can get cleared by the air blower present. And finally, the dust gets transported once the system is off. The dust gets transported through the mesh and then through to the conveyor belt. And then the conveyor belt, it is transported to a container, and which is then used to make the byproducts. So once an astronaut is free of 99% of the dust here, we have another system wherein we have a tunnel, and which contains of the air blowers. So once he passes through the tunnel, he gets completely cleaned over there because of the air blowers present for the secondary cleaning, and then he can safely enter into his moon base. So this is our idea of mitigating the dust. Could you please change the slide? Yeah, next one. Yeah. So what makes our idea a realistic one? So basically, we all know that industries use Helmholtz coil to generate high magnetic fields, low magnetic fields, and we also have seen clean rooms with air blowers. So that is also available, and the conveyor belts are readily available at industries, even at the airports. And the best part among this is we have the lunar simulant built here on Earth, which is not exactly equal to the one found in Moon, but yes, it does imitate this same thing, and it has 5% of non-magnetic material. So hence, it can be removed from air blowers. Next slide, please. Yeah. So we all we all know that handle permanent magnet is nothing but a bar magnet. So the bar magnet field strength is about 0.01 Tesla, and this graph here shows the variation of magnetic field when one coil is present and when two coils are present at equal distance, which is equal to the radius of the coil. And the formula to calculate the magnetic field is present here. And once we consider the parameters, which is shown like N equals 124, which is the turns of the coil, where B we already know, which is 0.01 Tesla, we obtain a current of around 53.8 amperes, which is definitely achievable. And we need not have to build very huge batteries or generators to get such amount of current. So yeah, this project seems feasible when it comes to mitigation of dust. Next slide, please. Yeah, over to you, Pratik. Hello.
Okay, so here is the estimated budget proposal from our project. So basically, if you see, we have done the survey on based on the Indian markets, because as we stay in India, accessing the Switzerland market is actually a little difficult for us and getting the exact amount. So what we did was like we just went through the Indian market, and this is what the basic proposal from the Indian market is, which totals up to around 814,500 rupees in Indian currency. But this is what we say is the highest, the high ending cost. Like this will be the highest cost possible, because when we start working on the project, we will try to configure most of the things by ourselves by directly contacting the industrial distributor, which will reduce the price drastically. So if we see the current highest price, that is 814,500 rupees, if converted into euros, that comes around 9,351 euros. So, and yeah, the prescribed budget, which was like limited budget, which was given to us by the academic committee, was 10,000 euros, and which we calculated to be like under 10,000 euros. So yeah, this is what the estimated budget is. Next slide, please, and over to you, Sejal.
Yeah, so everyone is concerned about the safety of astronauts. We all have a concern like what happens if when a person is standing in a magnetic field? Will it affect him? Will it harm him, or what? So according to the International Commission of Non-Ionizing Radiation Protection, a maximum amount of magnetic field sustained by a human body is around 0.04 Tesla. So, and here what the amount of magnetic field we use is 0.01 Tesla, which means it is not harmful for the astronaut. And we have some risk management factors here, that we will have a regular maintenance check of the clean room, and we have automated facilities so that manual work is reduced. And we also have a self caution given to the astronauts, because we have restricted the movement of astronauts, since the coil is a wider one and it is moving. Astronauts need not have to work so that they remove dust from their body. They can just stand still and the dust gets removed automatically. But standing still between a current carrying conductor would be a little risk. Although it's insulated, it would still be of a risk. But so we have provided them with a self caution statements, and like the thing which goes on in the industries here as well. So yeah, these are the risk management factors. Yeah, coming to the next slide, please. Yeah, so these are the references we have used. I hope you all have liked their idea, and I hope and we have seemed it to be feasible. Uh, hope you all have liked it, and we would just like to have some suggestions and feedbacks if you have. Thank you so much.
I have a question, please.
Yes.
Okay, they talked about using air blowers on the moon. And we know that the moon's atmosphere has limited air, in my opinion. So using air, is that not going to be too expensive?
It would be expensive at the beginning, but once we have like we also have said that oxygen is produced from the dust we have collected through electrolysis process. So yeah, we can recycle the air, because ESA is working on building a oxygen plant on moon, and it has also it has also produced oxygen using the moon dust. So yeah, once the process starts and once we have enough of oxygen and enough of air present, we can use the same air to blow the air in the air showers. Thank you.
Also, I would like to say that even entering any of the space settlement or any spacecraft, there is an evacuation chamber always. So we have to pressurize it somehow, and we have to add air somehow. So using the air that is used for evacuation chamber, we are using this uh, magnetic chamber as an evacuation chamber, so that so it so using the air that is actually being used in the evacuation chamber, we use the same air, so there is no risk for loss of any there is no risk for for producing any extra air to for this project.
And also the fact that these are mainly our test will be in the analog missions. So right now for the test purpose, we are good to go with it. And coming to the moon base, it's still going to be very long that we build a base over moon. So yeah.
Hi, thank you. I have another question. First of all, thank you for this great presentation. This is Chloe speaking, by the way. I wanted to know, if you were selected during the hackathon, what would you consider the next step for your team? Would it be the build of a prototype in India, for instance?
Can you please repeat? Your voice is breaking a bit.
Oh, I'm sorry. I was asking what would be the next step for you if you were selected during the hackathon. Would you see yourself building a prototype, for instance?
Yes, we will, once if we have selected, we'll start working on the prototype on this and try to test our different elements of the chamber. And once we test it successfully, we can go ahead with it.
Okay, thank you very much.
We would actually try a miniature one, so that we don't have to put all the budget inside the bigger one. And once the miniature one gets successful, we will try for the big one, original one.
Okay, thanks. So a miniature one would be, do you have an idea of a size of what you're talking about?
It would be like how do you say, an experiment set up in a science exhibition of that kind of miniaturized size. I can't exactly give you the dimensions, but yeah, like the science experiments which go on, it would be of that kind.
Something like which can be conducted in a science lab, something like that.
Yeah.
Okay, perfect. Thank you very much.
Thank you.
Okay, I have a question. So what if when you were doing your testing and you found out that the magnetic field that it was generating is actually much higher than you thought, and it's actually dangerous levels for people? Do you have any plan to mitigate this risk?
Yeah, if suppose while generating the magnetic field, it increases to a very huge amount, we would shift to permanent magnets. We would go ahead with either first we would try altering the electricity so that the magnetic field produced lowers, and if still it doesn't happen, we would then shift with permanent magnets.
Wonderful, thank you.
I've got a question as well, if that's okay.
Yep.
Yes, we have time for one more.
Yeah, I was just wondering, did you say you're gonna carry the gathered lunar dust on the conveyor belt?
Yes, we will collect the dust and then collect the dust in a container which is placed below the room or the chamber, and that will be transported to another chamber wherein it will be stored and used for the other purposes. So that transportation would be done by a conveyor belt.
Yeah, are you worried about potentially having charged tiny particles, possibly getting caught up in joints when it comes to conveyor belt, because you have motor and stuff like that, and especially in like when you're in like colder temperature as well, and lunar dust have like iron composition in them, like metals on metals, that's kind of, would you be worried about that?
But the thing is, we are trying, like once the dust falls into the container is basically made up of an insulating material. So I guess it won't get attracted to the conveyor belt structures. So I don't think that would create a problem. But if it creates, if while testing, if we find that it creates a problem, well, then we would try for another solution.
Okay, thank you.
Okay, great job. So the next presentation will begin in about 5 minutes. And thank you for your attention during the presentation. Good job.
Thank you so much. I hope you all liked it.
Yes, I'm sure we all liked it. At least I liked it. I can say that. I do have some questions in my head about it, kind of like 54 amps approximately. This is a lot of amps, which is quite dangerous. But other than that, I think that you've mapped out your example in a way that is, it does have potential, and it might be possible. Everything, I hope it's possible, right? Sounds good.
Yeah, just considering the fact that the human body is like works fine until 0.04 Tesla, and what we are creating is a 0.01 Tesla. So yeah, keeping those calculations is just a like, what do I say? It's not experimental; it's a theoretical calculation. So that's what's going on right now.